Hello, everyone. My name is Olson Sala Jr. I'm an escalation engineer, and thank you so much for watching this video. This is about configuring failover in Azure UDR setup in KB S37558. Before anything else, thank you. Huge thanks to the dev, Maniva Sakam, for putting all these steps together, and to Chris Harvey for the configuration guidance. Now, there are many ways to achieve this failover for the Steelhead UDR. This is just one example. Riverbed support does not design scripts, nor we do not troubleshoot for customers because this is everything in Azure. Now, first that we're going to do is we review the setup in the KB, the working one. So here is the diagram, and we have a working scenario. So here we have a client machine. We have it in riverbedlab.com, and we installed Steelhead Mobile, and we also have a VPN client installed here. So we have VPN tunnel to Azure. Now in Azure, we have 3 subnets. Please take note of the subnet names because we'll need this for the scripts later on the later configuration steps. So the first subnet is the gateway subnet. This is where the VPN connection terminates. Next is the acceleration subnet, where the Steelhead is located, and the server subnet, where a server lives. Now, the logic here for the UDR redirection is we create a UDR or static route in gateway subnet. So when the traffic hits the gateway subnet destined to our server, instead of directly going to the server, we redirect it to the Steelhead. Same with the return traffic. Instead of going directly to the client, we redirect it to the Steelhead. So that's the UDR logic. So we have a working setup right now, again, in the Riverbed Lab. So this is our client, and we are able to ping the server, and we can see the traffic being optimized. Let's do a telnet test. Here's our cloud Steelhead. See it optimized right here. Port 7800 right here. All right. Now, here are the configuration steps. So basically, the steps here will be based on our setup, the IPs, everything, the name of the subnets, everything. So first is we create an empty route. We'll need to use this empty route so that when the Steelhead is down, we will assign this empty route to both gateway subnet and server subnet, effectively removing this UDR routes. So we bypass the Steelhead. Second is to create an API management service. It's just an API call to the Steelhead to determine if it's up or down. The web service URL is this. We will use this in the configuration later on. And next is the automation account. We create a runbook. Runbook is the script to configure the routes on our subnets, and the webhook actually gets triggered. So when for example, when Steelhead is down, this webhook will do an HTTP post. So it will modify the runbook script to remove the routes, or basically apply the empty route that we created here in step 1, basically bypassing the Steelhead. And then the last will be creating a logic app, which ties all these things together. Okay, let's start. I recommend you to take a screenshot as you follow along with the configuration steps. So I'm going to move this over. Step 1 is to create an empty static route. So this will be used when the Steelhead is down. So I have 2 Azure portal tabs here. Go to route table and create an empty route. Give it a resource group, and then give it a name. Let's just do bypass SH. Right, and create. All right, that's done. Next is we create an API management service. API management service here. Now, creating the API management service takes a while, like 42 minutes to an hour. So I already pre-created this, but for demonstration purposes, let's create one. Just going to show you. We're going to go through resource group and make sure that our region is consistent. US West 2, give it a name, give it an organization name. Okay, let's just an example, administration name. Oh, an administrator email, I mean. And then that's it. Review and create. Okay, let's exit out of here. And then once we created an API, just click this and create a new API right here. Add a new HTTP API. Give it a display name. Let's just put SH monitor here. And the web service URL, this is the URL on the document. So I'm copying and pasting it here. So this is just basically the public IP of our cloud Steelhead, 20.109, 20.109. All right, create. Next is we add an operation, or not yet. We need to disable the description subscription. So go to settings and disable the subscription. Okay, and then go back, go to design tab and add an operation. Give it a name again. Let's just do the same name, sh monitor. It'll be a get operation, and then just do hashtag here, and then save. And next is we import the web certificate of the cloud Steelhead here to this API management service. So you want to go down below to certificates. And importing this the certificate takes a while, again, 30 minutes to 40 minutes. So I already imported, but for demonstration purposes, first you want to go to your Steelhead, go to the web settings page, and copy the PEM file, the PEM certificate. Save it in a notepad, and make sure to save it as a .cer. So cert name .cer. It's very important. It doesn't accept .text or .pem, but you need to use .cer. And then choose all files here. Click on save, and once you save that, just click on add here. Store will be trusted root, and then select the file here. All right. Once we're done, we'll go back to the API, and we're gonna go ahead and do a test. Just exit out of here. Click the SH monitor that we API SH monitor that we created. Click the operation. Go to test, and then send. All right, so we get a response, 200 no content. Green means good, it's up. So what we're actually doing here is the API management service is just checking the Steelhead to see if it's up or not. It got a 200 code, which means it's up. So we're done with that. Next is create an automation account. So automation account here. Let's create one. Give it a resource group. Give it a name. And then region, make it consistent. All the others, just leave it as it is. Create. Okay, it's done. Go to resource. And then first is we need to add a network contributor role for this assignment for this automation account. Scroll down, look for identity. identity. Okay. Click Azure role assignments. Add a role assignment. Just ignore this error. Scope will be resource group. Resource group, select a role, network contributor. And then save. Yeah, it's done. Okay, next is we create a runbook. Go back to the automation account. Let's go back to the automation account. And then here's the account that we created. Click, and then look for runbooks under process automation right here. And then we create a runbook. Give it a name. Type will be PowerShell version 5.1. Create. Okay, and then this is the script. We already have a template for the script, but I will share this script in the internal notes section of the KB. So copy, paste. There's not a lot of things that we need to modify here. So first thing that we need to modify is the virtual network name. So our virtual network name is this. Let's look for the virtual network. Okay, virtual networks. This is our virtual network. This is the name. So just copy this and paste this here. Resource group, overview, and this is the resource group. Copy, paste. All right. So first is the acceleration routes. Notice that we have two routes here: server subnet and gateway subnet. Remember on our setup is the server subnet and gateway subnet. And under our virtual networks, we do have these subnets here as well: server subnet and gateway subnet. So for the server subnet, for this acceleration routes, this is when the Steelhead is up. So when the Steelhead is up, the script basically says, hey, do this, use this route table, which is the current route table. When the Steelhead is down, we're going to apply the bypass route table that we created at step 1. Okay, so let's start. Server subnet, what is the subnet? Okay, go back to that page. Servers, that's server subnet. Okay, server subnet, copy the subnet here. I'd like to paste it first in a notepad to get rid of those formatting. Then paste it here. All right, so when we're optimizing, when we're accelerating, what is the route table that we need to configure? It is this route right here, Azure to server route. Just click this, copy the URL, starting from subscription. Make sure that you include the / all the way down to the name of the route table. Copy and paste between the quotation. Okay. Now gateway subnet this time. What is the subnet? Hit back. It's this. And then what is the route table for gateway? It's this one right here, virtual network gateway to Steelhead. Click and copy the URL. Okay, and then this next, it will be the bypass route. So same thing, let's just copy the subnet, server subnet, specified here, gateway subnet. Now, when the Steelhead is down, the webhook will be called, and then it will, the runbook will apply this route. So what is the route table? The route table that we will use when the Steelhead is down is the bypass route table that we created at step 1. So let's go to route table, bypass sh, copy, including again the / all the way down to the route table name. Okay, we're gonna use this for both subnets. All right, that's about it. Leave everything here as it is. Just checking, double checking before we hit save. Your server subnet is .2. Server subnet is .2. Okay. All right. Click on save and then publish. All right, we're done with that. Next is we create a webhook. Webhooks right here under resources. We will create two webhooks, one for bypass and one for optimize. First, we create the bypass. Take note of this expiry. By default, it's only for 1 year, but make adjustments to your customer. Now, it's very important to copy the URL. We're going to use this in on the later configuration under Logic app. If you miss to copy this URL, you need to create a new webhook again. So bypass, copy the URL. Okay. And then OK, set the parameters. So bypass acceleration, put 1 here and verbose 1. Okay. And then create. And then add a webhook again for optimize. Copy the URL. Okay. And then for parameters, just leave it. I'll leave everything as blank. All right. So we're done with webhook. We'll create logic app this time. So logic app. Okay, let's click on add. Put a resource group. Let's give it a name again. Workflow region is West US2. Plan type, consumption, and create. Create. All right. Go to resource. So it's going to redirect us to Logic Apps Designer. And we will create a blank logic app. First, choose the first operation, which is recurrence. Schedule. So every 30 seconds. Okay, that's done. Add a new action. Look for API management. Azure API management. And then this is the API that we created earlier. SH monitor again. Okay, it's done. And then settings, look for retry policy, set it to none. Okay, done. Next is we create a condition. Add an action. Search for a condition. This one right here, control, condition. And then parameters, we're going to use status code greater or equal to 200. And then add a new row. Status code again, lesser than 300. Okay. And then, so this basically means that if every 30 seconds, the logic app will check the Steelhead GUI if it's up or down. Now, if it gets an HTTP code between 200 and 300, it's going to be a true statement. If it's anything else, it's going to be a false statement. And then run after, expand right here, and then tick everything. Okay, we're done with that. So if the Steelhead is up, this means it's true. Let's add an action. An action will be the HTTP. It's going to be a post method. And we're going to use the URL of the webhook that we copied earlier. So if the Steelhead is up, condition is true, and we want to optimize. So copy the optimize URL. And then if the Steelhead is down, still the same, HTTP. Method will be post. URI will be for bypass. All right. So I think we're done. Save. And I can't remember if I showed an example that we are optimizing a traffic from our client machine. So just as for a demonstration, this is our client machine in Riverbed Lab. This is us right here. So we're gonna do a telnet test to this server over 445, and it should be optimized. Telnet, and we should see it here. All right, so it's optimized. Now, going back to our Logic App Designer, we should be all good. We should be ready to test. So we will reboot this Steelhead, simulating a down scenario. Okay, let's do a continuous ping. Okay, now the route table should change here. Okay, started to time out. I think since our schedule is every 30 seconds, it should be 30 seconds max till it detects. Okay, so the webhook data right now is bypassed. So we would expect this to change now. All right, bypass SH. So right now we're bypassing the Steelhead. We go directly to the server and go directly to the client. And we can see here should still be I noticed that there's like a slight delay, but let's see. Should still be able to. Okay, there was like a small delay earlier when my testing, but yeah, we're still able to ping the server. Now, once it goes back up, we would expect the route table to get updated here. Okay, let's wait for a while, maybe 2 minutes, 2 to 3 minutes. All right, looks like it's back up now. All right, it's up. Let's refresh. It's still bypass. Let's look at the runbook logs. Data is still bypass. All right, data is now optimized. And this should be, the route table should be back to the original. All right, there we have it. Configuration for a failover. Thanks for watching.